People always seem to really struggle with word problems that ask you to figure out how long it'll take for you to double your investment or reach a certain number of dollars in your bank account or triple your investment, or if it were decay for something to get down to this much. And it's really not all that bad. So let's try this example here. How long will it take to double $6,000 when it is invested at 5.9% annual interest? If interest is being compounded, you have to use a specific formula. Compounded n times per year or compounded continuously, and that will more or less decide which formula you use. However, if interest is not being compounded over the period of a year, we can use this formula. A equals P times the quantity of 1 plus R to the T. $6,000 is our initial investment, so that's going to go in for the P value. R represents rate. Our rate is 5.9%, which means 5.9 per 100, which means 5.9 divided by 100, or 0.059. If we fill that in for the R value, our 1 plus R, or the entire quantity inside of the parentheses, will equal 1.059. In our next step, we are going to look at the fact that the problem is asking us about doubling our investment. Our investment was $6,000. When you double something, you are really multiplying it by 2 because you will have 2 of that amount. If I double my P value, or principal primary investment, I will get P times 2, which is 6,000 times 2, which equals 12,000. That means I want to know how long will it take for my A, or amount at the end, to reach $12,000. The fact that the question says how long will it take tells me that I'm solving for T, or time. T is in the exponent, which means we'll use an inverse of exponential, which is log. If we take everything that we've gathered from the equation so far and fill it into the equation and rewrite it, we'll have 12,000 equals 6,000 times 1.059 raised to the T. If I start fresh on the next page with this example, we're solving for T in the exponent. Before we can use any sort of log, we need to isolate the base to a power. That means we need to divide both sides by 6,000 to begin. After we divide both sides by 6,000, we will have 2 equals 1.059 to the T power. Now there's 2 ways we can proceed from here. I'm going to show you the classic way first. First, we're going to take the log base 1.059 of both sides. Log base 1.059 will eliminate the exponential of 1.059 to a power. It will leave us with just the T variable. Then our answer T equals log base 1.059 of 2. We can use the change of base formula to find what that's equal to in our calculator. I'm going to use ln because the natural log is a very convenient button on the calculator. ln of 2 over ln of 1.059 is equivalent to log base 1.059 of 2. When we put this in the calculator, we get that it will take approximately 12.09 years. Fun fact, in this account, it will take 12.09 years for any amount of money to double. If you invest $1, it will take 12.09 years for that $1 to double into $2. Now I'm going to show you a less roundabout way, sort of direct little shortcut. We'll pick up from the step where we had 2 equals 1.059 to the T power. Instead of using log base 1.059 and then implementing change of base formula later, we can just take the natural log of both sides now. As long as we use the same type of log on both sides, we're fine. After we take the natural log of both sides, since we have one term raised to a power on both sides, 2 is raised to the first, and 1.059 is raised to the t, we can now use the power property to bring the t exponent out in front of the ln 1.059. In order to get that t alone, isolated, solved for, we need to divide both sides by ln of 1.059. Once we do this step, ln of 1.059 over ln of 1.059 on the right reduces to 1 and t is now alone. The left side says ln2 over ln of 1.059, which is exactly what we had solving the other way after we used change of base formula prior to using our calculators. I tend to choose the second method because I think it's a little bit cleaner and less to write down, and it gets the same answer. It gets the job done in fewer steps. I hope this was helpful and you were able to understand how to solve for time when working with an exponential equation.